Function as a service is a core building block of serverless technology. The reason why it's a core building block is that it is the simplest unit of work that you can use to build some kind of application or microservice or some kind of event-driven protocol. If you take a look at the workflow, it is a piece of code, for example, an add function. This could be in the logic, and then that input that goes in would be, let's say, an X and a Y. You would do the work, and then at the very end, you would return back the result. And this is as simple as it is. And this is what makes function as a service so powerful and also so scalable, is that you can look at it and you know exactly what it is going to do. Likewise, some of the most popular frameworks take advantage of this. A good example of probably the most popular function as a service framework is AWS Lambda. With AWS Lambda, you can attach it to S3 notifications, like, for example, putting a file, or you could put it in attachment to SQS, simple queuing service, and you could call AWS Lambda every time a message shows up into a queue. And so what happens is when you cascade these things together, you can build effectively infinitely scalable services that also have a very small response time. This is also why Rust as a language is probably, let's say one of the top two languages for building serverless because of the speed, the safety, and the deployment characteristics of the language. Maybe the other language could be Go. These modern compiled languages give you the ability to optimize for serverless and get millisecond response time, millisecond invocation, very low energy use. And that's something to think about in the function as a service world. Is you should be focused on maintaining the software, lowering the cost, not necessarily the ease of building it, because the maintenance and the total energy cost and total financial cost of the service is really something to think about when you're building function as a service.